Okay, so what we're going to do is take a look at the water cycle and just go through a couple things for you. This won't take very long, so I promise you I'll make it quick and to the point. Water cycle. Well, first of all, here's another map you can look at for the water cycle, but you can see there's red arrows pointing everywhere in the direction that things are flowing. The thing about the water cycle is it's always constantly going. So as you've been seeing in the last couple of weeks, rain, snow, you name it, it's all part of the water cycle. Now, you've seen this picture right here, probably if you've had me before, except for the only difference is this one has all the names in it. And so when we talk about the water cycle, we're going to talk about a few things. Now, they call it the hydrologic cycle as well. Hydro just means water. So if you're like, what is hydro? Hydro is just water. And you should know that because you guys are a bunch of Visco girls with hydro flasks, right? Yeah, that's a joke. Hydrologic cycle is what we call it, but the water cycle is just the easier way of saying it. And the biggest thing is it's just the process by which water circulates between the Earth's oceans, atmosphere, and land. It's got water storage in it, evaporation, transpiration, condensation, precipitation, runoff, all those wonderful things. But I just want you to really know the 5 main steps, which is radiation. Number 2, radiation, of course, being from the sun as it radiates from 93 million miles away. Radiation and then evaporation. That's where water goes from being a liquid and it evaporates into a gas and it goes up into the air to evaporate. And then when it gets to evaporation, that's where we go into what's called condensation. Number 3, condensation. This is where the gas clumps together and becomes a water droplet again. Yay! Bunch of water droplets come together and you get what's called a cloud. Pretty cool. And then it moves on, and as it moves on, that cloud gets so heavy that eventually it starts to lose all those water droplets to the earth in what we call precipitation. That's number 4, precipitation. And then the last step, number 5, is where the water collects. Could be right here in a lake, could be in a river or stream, could be underground, could be back in the ocean. We call this collection. There are the 5 main steps to the water cycle that I want you to know. 5 main steps. Okay. What about water storage? Based on this image, where does stored water eventually go? That's a good question, Mr. Jensen. Well, stored water could be up here, the ice and the snow. It's stored up in there. There's glaciers up there. There's precipitation that hits and becomes runoff or snow melt. So eventually it gets warm and it runs its way back down. Or you could get rivers and streams flowing into freshwater lakes. Groundwater is another great thing that can happen. You can get water stored in ground. In Chini, we get a lot of our water from the ground. Water that's been stuck down in the basalt rocks. So based on the image, where does stored water eventually go? Well, it eventually makes itself through and it will end up back in the ocean. So it'll eventually go back into the ocean, or it could just stay in a lake, or it might just get trapped in the ground. There you go. Ocean, lake, and ground. Good times. What about evaporation? In this image, where does evaporation happen? Well, a couple circled here. Evaporation happens right here by the ocean as all those particles vaporize up. Same here. It could happen in a lake too. It could happen in ponds. But there's also evapotranspiration, which means on a plant leaf, there is a chance for it to evaporate off of plant leaves. Remember, plants bring water into the root system. So there's a chance that that can happen as well. Evapotranspiration is what we call that. So it could happen on land, and it can happen in the ocean. Okay. What about transpiration? Based on the image, what does transpiration bring water? Well, transpiration can bring water up into the atmosphere as well. It's just that it's on land. but it can bring water right up into the atmosphere. And again, that could be from a plant leaf, possibly. That's one way to get it. It could be from trees. It could be from ponds. It could be from all sorts of different areas that water could be sitting at. Condensation. What is that again? Well, remember, a vapor as a gas means that the H2O water molecules, so our oxygen hooked to our two hydrogens, is very high energy. And because of that, it's moving very rapidly. But if you cool down a vapor, if you cool it down, eventually those vapors are going to come together and they're eventually going to turn back into a water droplet. And so when you cool things down, they come back into a water droplet. And so condensation is where we go from a gas to a liquid. And to do that, we have to get cooler. We lose energy. And then we've got precipitation. What is precipitation, Mr. Jensen? Well, we've got different forms of precipitation. We've got stuff that you've probably known about for a long time. Rain. I don't know if you've heard about that. Rain's precipitation. Snow right now in the cold times is precipitation. And we're storing up snow right now up in our mountains, which is great. We need a lot of snow stored up in our mountains. And in this, that stored snow can actually start to melt in the springtime. And when that melt happens, we get what's called runoff or snow melt. And what it does is it pours into rivers and streams, and those rivers and streams flow into lakes where they can store water and go back into the ocean. It can also seep through infiltration right into the ground and create groundwater. So groundwater storage is a big one too, aquifers and things like that. Based on this image, where can runoff bring water? Runoff can bring water to oceans or streams or forests, all sorts of places. Runoff is just that. It's just running off into different directions. Yeah. What about this, Mr. Jensen? What about the water storage on the earth? Well, check this out. Most of what you see down here is actually showing us where most of our water is stored. It's right here in the ocean. That's where most of our water is stored, is in the ocean. I know, 96.5%. There's water with saline in it. There's water with salt in it. But fresh water is about 2.5%. Fresh water is only 2.5%. That's crazy when you really think about it. So the ocean is the major super storage of most of the water, but it's salty. We can't drink it. We can only drink fresh water. So we only get 2.5%. Now, from that, you can then go into here and you can look at groundwater, which is about 30%. Glaciers and ice caps is a big place where we store fresh water. And then surface fresh water is 1.2%. Not a whole lot. So this is what we usually can reach and get to, is the groundwater and the surface water. That's what we can get to. And then if you even look into another section of surface water, just talking about our atmosphere and the permafrost and lakes, it's not very much. There is not a whole lot of fresh water out there, as you probably know. We're constantly digging wells in Africa and all over the place looking for fresh water, because fresh water is what we drink. We can't drink salt water. So that is a kind of interesting thing. Is there more or less or the same amount of water on Earth as there was 2,000 years ago? Explain your answer. Well, remember, we have that thing on the first atmospheric layer known as the troposphere. That's the first layer of the atmosphere. And we have that section that we call the tropopause. The tropopause. You'll know it's there because the temperature stays the same for a while and it pauses. And what it actually does is the clouds and the evaporation, the clouds can't go above it. It's amazing. It pauses then because it's too cold. So because of that, we don't lose all of our water. And actually, the same water we have now is the same water we've had for the longest time. There's the same amount of water today on Earth that there was 2,000 years ago. The water on Earth is always being recycled through this thing called the water cycle. Now, the Earth is not gaining or losing water. The water only changes forms basically depending on temperature or the amount of energy interacting with the water. So we can get ice cubes happening, which you've seen before. Ice is a solid. You can warm it up, and eventually that ice becomes liquid, and you get these little liquid droplets of water. And then from a liquid, you can really add energy and warm it up. And when you do, that's when you get vapor. And the vapor is the warmest thing. That's back into that gas. What about condensation? Explain this to me, Mr. Jensen. Process in which water vapor in the air is changed into a liquid? What does it mean a loss of energy allows water molecules to bond? What does this all mean? Well, let's say you take this cold glass right here, and let's say the glass has ice in it, and so this is extremely cold right here. And you've got water vapor in the air. This is all vapor in the air. Well, with that water vapor, as it travels and makes its way through, if it touches that cold surface, it'll turn back into a water droplet. And you'll see this sometimes on your glass, or if you wear glasses like me, you'll see it on your glasses, but you'll see this on your glass, and it looks like, oh my gosh, it looks like sweat on your, it almost looks like sweat on your glass. You'll see all these droplets of water starting to condense on your glass. And that is condensation. That's the vapor in the air touching the glass and going back into a droplet. Yep. All right, if I look at this water cycle picture and I use this answer bank on the left-hand side, let's see if we can just go through this really quick and just kind of talk again about this. Well, obviously we have radiation. Radiation is the biggest thing that drives this because it's the sun. So we have the sun's radiation. Super important, but we also have evaporation happening in our oceans. Cross that one out. Goes up, it cools down as it expands and gets colder up into the air. And when it does, we get what's called condensation. That's what we get next, is condensation. Then from the condensation, this is where it really starts getting crazy, because condensation then moves in and all of a sudden it gets so thick with water that you get precipitation. Precipitation. That's any form of water that reaches the surface. So it could be snow, like up here is snow. It could be rain. It could be hail is another version of it, or sleet. And then when it rains, it reaches the ground. And what you get on the ground is sometimes you get infiltration. And infiltration happens when the water seeps into the ground. And then when the water seeps into the ground, you can get what's called percolation. And that's where, like, if you had sand grains like this, percolation is just the water seeping through. So if I was a water molecule, I could start to fill up all the empty space between sand grains and travel into the ground until I eventually get down to the bottom, which is the groundwater. Because it's in the ground, right? Water in the ground makes groundwater. All right, so we got runoff, we got percolation. Ooh, transpiration. We forgot that one. Again, transpiration. This is right here. This is when there's water, specifically on these trees and things, and that water evaporates up. Transpiration. That's how we get water into the atmosphere from that. Precipitation we got. Infiltration we got. Groundwater we got. I think we got pretty much everything. Oh, yeah, this was just runoff. Yep, just water flowing back into the ocean. Okay, that pretty much solves everything. I mean, the only thing is with runoff, I guess, is you could say, well, what about this whole runoff idea? We have precipitation that did not get absorbed into soil or evaporate. We call this runoff. That's what we call this. Ice caps, glaciers, they provide runoff. and all sorts of things. Water moved by gravity makes its way into places that water collects, rivers, lakes, ponds, streams, all that kind of stuff. Why does it happen? Well, you've probably seen runoff specifically in springtime. If you over water and the water can't seep in between the grains of sand and it fills it all the way up, it'll run off out the edges. And so you'll get water runoff all the time. We get the Westwood Lake out here and we get tons of water runoff flowing through, and it looks like a whole marshy, swampy area after a while. So again, in our water cycle, if we are to talk about a few things, I just want you to understand what infiltration is. It's just the downward process of moving water on the land surface into soil or porous rock. That's all it is. So water will filtrate into infiltration. If you've ever dug down to like what's called the water table, you'll notice that, oh my gosh, I can actually dig down to water. If the water table is really high, that just means that a lot of the water in the springtime, a lot of times starts filling up because there's so much rain. And so the water table gets really, really high. And we call this a high water table. And sometimes we just have water standing. Groundwater in our aquifer is deeper, though. We have a Spokane aquifer and a Rathdrum aquifer. And this is like it's literally an underwater river. It's flowing water, which is so cool. And we have one of the best aquifers in the world, which is amazing, right here in Spokane. A watershed is just, if you were to go to the highest points like this is, and you were to look at the highest points, anytime rain comes down, it's going to go either down one slope or the other. And so we can draw what's called watersheds, which is when all the water flows into one area. And when it does, it collects into streams like what you've seen in the Spokane River, and then it flows back out to the water out in the ocean. It could be small, like a footprint, but it could be huge, like massive land areas like the Mississippi River. That's it, folks. That's all I have for you today. I hope you enjoyed that asynchronous lesson, and I hope it clarified a few more things on the water cycle. We'll talk to you later and see you in class soon. Goodbye.